Okay, good morning, afternoon, or evening. Today is day 2 in the pre-cal series and sequence unit, and we're going to be looking at arithmetic series today rather than sequence. And we're going to look at how that is developed and do some examples in the area. It should be about around that 40-minute range today. So this is arithmetic series today. And this is section 1.2 in our text. And what we're going to be looking at today, we've got a job of looking at we will look at and develop the two formulas that come in this unit for sum of series. I guess it's an arithmetic series. Okay, let's slide my face out of there. Okay, that's the first thing we're going to be doing, and we're going to be looking at, we're going to define series. We're going to do the definition. And then finally, we'll do some examples. And then practice. That's our ideal for today. So the first thing I want to do is I want to talk about an arithmetic series. What is an arithmetic series? It's the same as a sequence, except you add the numbers together. That's it. So basically, it is an arithmetic sequence where the terms are added together. And it has in their book, they talk about the guy Gauss, who in the 1700s or I think it was late 1700s, when he was like 6 or something or 7, his teacher says to him, the class, okay, I want all of you to find the sum of the first 100 numbers. And Gauss did it in like 30 seconds. Well, because he came up with a formula for it, how to do it really quickly. And I'm going to show you how he did that. So what Gauss did, we'll just do a little example of it here, is he, let's get my marker out here. There we go. Okay, so if we did 1 plus 2 plus 3 plus 4 plus 5, so then what he did was he did this. He went backwards. And then he added them up, and it ends up, all these are 6, right? So then it was 6 times 5. So what is it? It's n plus, it's the first term plus the last term added together, right? Times by 5. So if you're looking at that, this would be what's 6 plus 6 plus 6 plus 6 plus 6. And then because you have 2 series here, you want the sum of one series, you're going to divide it by 2. So this would have been just 30 divided by 2, which equals 15. And that's how but he did it from 1 to 100. So he had 101, right? He had 1 plus 100. So he had 101 times the number of terms, which was 100. And then he divided by 2. So he developed the formula for it. So the formula, based on some 6-year-old that figured this out when Gauss did a lot of really, really, really important things was he took the first term, we'll call it T1. He added this last term, we'll call it Tn, and he multiplied it by the number of terms, we'll call it n, and then he divided everything by 2. So we'll just put, so there's the formula, and that is equal to the sum of the series, which we'll call Sn. And that's the formula that Gauss came up with. Okay, so we'll define everything. Sn equals the sum of the series. Okay, and it's arithmetic. N is the number of terms. Okay, and then Tn is the final term, or whatever the last term might be. So we'll call it the Tn is the nth term of the series, or the last term usually that you're going to add up to. And then we had D. Well, we have to know what D is, because we're going to add, well, we don't have to know for this particular one, but we're going to add in what is the common difference. We're going to get a second formula. Okay, and Sn, N, T, and T1 is the first term. Okay, so Gauss came up with this formula right here. Okay, now we know we can do a math substitution thing. We can come up with a second formula. So we know that Sn equals, I want to write it in this form, n over 2 times T1 plus Tn. Okay, that's Gauss's formula that he came up with. Okay, for the sum of the series, it's equal to number of terms divided by 2 times the first term plus the last term together. Okay, now if we know from last unit that Tn is equal to T1 plus D times n minus 1. Okay, that's how you find the nth term. So if we take this and plug it into where Tn is, we can come up with a second formula. So let's sub in, let's call this equation number A and equation number B, and let's sub A in for Tn into B to get a second one. Okay, so if we do that, if we take Sn equals n over 2 times T1, and now we're going to put in T1 plus, and then we're going to put it in the square brackets here. We'll go T1 plus D times n minus 1. Okay, and then if we remove the brackets here, we can combine these two to make two T1s. So this gives us a second formula available. Sn equals n over 2 times, removing the back, that's 2 T1s, plus D times n minus 1. Okay, so there is a second formula available to us there as well. Okay, and so we have two formulas that we can use. If we have the last term or nth term in the first term and the number of terms, we can use this formula. If we have the number of terms in the first term and the common difference rather than the last term, we could use this formula. So let's summarize that in the next page here. So two possible formulas. For sum of an arithmetic series. Arithmetic, can't spell it like that. Okay, so we had the first one that Gauss came up with. N over 2 times the first term plus the last term, or the nth term. And then the one we just finished deriving, N over 2, and then we'll put square brackets, is what the book usually does, T1, 2 T1s plus D times N minus 1. Okay, so this one, if you have T1 and D and N, this one if you have T1 and Tn. Okay, so let's take a look at some examples using these sum formulas today, and then we'll do some practice as well. So let me get my timer here, see how long we're going here. So we're in about 11 minutes here, so we'll spend another about 20 minutes or so doing a few examples dealing with different kinds of questions that come up with in finding the sum of series. So one of the first types of questions is if they just give you a partial series and you have to find it. So let's say we have find Sn. Okay, it's an arithmetic series. So let's say we had -6 plus 1 plus 8, and we went all the way up to 141. Okay, so there's our series, and we want to find the sum of the series. And the series is because it has pluses in there. Now, a series can also be, when we go back here, right? So an arithmetic series, so I should have given you an example here of what they look like. I gave you 1, 2, 3, 4, 5. That's an arithmetic series added together. But if we do what an example might look like for series, you could have, 2 plus 4 plus 6, ... Or you could have subtraction in there. So you might be subtracting as well. So you started, let's say, with 5, then you subtracted 3 to get 2, and subtracted 3 to get -1. Don't need a comma in there, sorry. So I should have gave you a couple different examples, and you could keep on going, or you could terminate the series. So minus another 3 would be -4, minus another 3 would be -7, and so forth. So that's an example of what they look like. So when we go into here and say I have this 6, -6, then a +1, then a +8. So I'm adding 7 every time. So the first thing is to write our variables that we know. So we know that the first term is -6. We know that the final term is equal to 141. Okay, we don't know what n is, right? So that's a bit of a tricky part, right? And in either formula, we have to have an n. Okay, so step 1 is to find the end. How many terms are there until we get to 141? Well, you could write it out, or you could use the formula. So we know that Tn is equal to T1 plus D times n minus 1. So if we plug in all the numbers that we need to know, we have to find D here, which I haven't figured out yet. So what is D? Well, D is just the difference between terms. So if we take 1, subtract -6, that is equal to 7. So we're adding 7 there, we're adding 7. Or you could do 8, subtract 1. So D is 7. So if we plug in 7 and we plug in -6 and we plug in 141, we can solve for n. Okay, so 141 equals -6 plus 7 n minus 1. Now, we have to distribute this so that we can solve for that. So the first thing I'm going to do is I'm going to add 6 to both sides. And then I'm going to multiply 7 times n and 7 times -1. Okay, so then I'm going to have to add a 7 to both sides now. Okay, so if I do that, yep, add 7, we get 154 equals 7n. Divide by 7 to get our n. 154 divided by 7 is 22. So now we know what the n value is. So now we can use Gauss's formula up here to figure out the sum. Step 2, calculate the sum. So Sn is equal to, well, this is the easier one to use because we know the final term and we know the first term, they're given, and we know n. So we're going to go n over 2 times t1 plus tn. So in our case, the sum is going to equal 22 divided by 2 times -6 plus 141. Okay, do some math here. Let's slide this up so we can see it a little better. This becomes an 11 and -6, pardon me, added to 141 is 136. Multiply those two together, and we have our sum being 1,485. Okay, so there's an example of you have to do a two-step thing because we have to find out what the n, when the n value is not given. Okay. Sometimes they'll give you a series without the final term, so you'll have to use the other formula. So let's do an example like that as well. Okay. So let's do another example. Okay, so let's say I had the series -7, -11, -15, dot, 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 and I go all the way up to the 23rd term. Sometimes I'll put S in there. And it says find the sum of the series. Okay, so in this case, we have n, because it's this 23, there's 23 terms. We have the first term. We don't have the final term, so we can't use that first formula. We have to use the second formula. And we have to figure out what is the common difference. So -7 to -11 is -4. -11 to -15 is -4. So our difference here is a negative number in this case. Okay, I'm going to pause here. You've probably heard my phone going. I'm just going to quickly check, and then I'll be right back with you. Okay, sorry about that. Okay, so we're going to be looking at the second formula, the one that we derived. We're going to be using this one here because it has n, it has d, and it has t1. So we can just plug that in. Okay, so we're going to be, it's just a one-stepper in this case. Sn is equal to, using that formula, making sure we write it out, n over 2 times 2 t1s plus dn minus 1, like that. Okay, so let's plug in our numbers. So we got 23 over 2 times 2 times -7 plus -4 times 23 minus 1, which was 22. Closing the bracket up. So this is going to give us our value here, 23 over 2. And this is going to be equal to -14 minus 88. Okay, so we got 23 over 2 times a negative 102. So that would be like 23 times half of negative 1 over 2, 23 times negative 51. So that's negative 1,173 for our final answer of the sum. Okay, so there's a couple examples of doing a sum of an arithmetic series, which using Gauss's model and his first and the second equation, which he re-derived. Okay, so I'm going to do a third example, probably finding something different. Okay, so we basically did finding sum both times. Well, let's try finding T1 or something like that. So this will be our third example. So let's say we have so let's say this is like finding the first term. Find T1, let's say, given Sn equals 58. The number of terms, there's 16 terms, and the common difference is 5. So they give you some information. Okay, so we know that we have the common difference, we have n value, we have the Sn. So we have to choose which of the formulas. Well, we don't have the final term, so we got to use the second formula. Right? So if we think about it, we can use Sn equals n over 2 times 2t1 plus d minus n minus 1. And we can just plug in our given numbers and then solve for the unknown. So this is 58. So put a 58 here. This is 16 over 2. Unknown t1 plus 5 times, okay, now we have 16 minus 1, which is 15. Okay, so then we have to do some simplification here to get t1. Okay, so we'll keep this like this. We'll break this one down to 8. Okay, and then we'll go 2 t1s, and this will be 15 times, 5 times 15, pardon me. So that's 75. Okay, now how do you solve this? Well, a couple ways you could do it. You could expand it out and then move everything around, which is what I'm going to do. So I'm going to expand it out. 8 times 2 t1s is 16 t1s. And 8 times 75 is, what is that, 600? I think. Better check that one on the old calculator. I'm a little rusty. Yep. Okay, so now we just work it out. Subtract 600 from both sides. So if we do that, you get negative 542 is equal to 16 T1s. So let's divide that out here. It's not going to give us a whole number, is it? Which is unfortunate, but that's okay. Oops. So we had 58. Oops, I got that. Okay, so we got negative 542 divided by 16, which is giving me negative 33.875. So I got a decimal number, or if you want it in fraction form, it's negative 33 7/8. Doesn't matter which one you use for that. Okay, so there's a couple examples of doing sums of series. I think we'll do one more here, and then I'll give you some practice. I'll get us into about 30 minutes. Let me just pause this a second and dig one up here. Okay, I wanted to do one with a fraction in it because fractions sometimes freak people out. So made this one up here. Find the sum. Okay. You can do decimals or fractions. We'll do one with fractions. Okay. So we know what the final term is. Oops. Don't need the eraser. I need my marker here. We know what the final term is. So this is Tn. This is T1. And we don't know what D is right now. We can figure that out. And we don't know what N is. So let's work out this one. So we're finding D. So D is going to be 3/2 subtract 3/4. Okay, so common denominator, this is 6/4 subtract 3/4. So that equals 3/4. So D is 3/4. Okay, now we're going to have to figure out what, we know what the final term is, we know what the first term is, we know what D is. We have to figure out how many terms there are. So we have to use our formula for that. Tn equals T1 plus D times N minus 1. And we want to find N. Okay, Tn in this case is 51/4 equals 3/4 plus 3/4 times N minus 1. So let's expand this out before I do too much work here. So this is going to be 3/4 plus 3/4 N minus 3/4. Okay, so these cancel out. Okay, so we got 51/4 equals 3n/4. Okay, that's what 3/4 is for. So if we multiply both sides by 4, the 4's cancel out. And then we can divide by 3. So 51 divided by 3, n is equal to 17. Okay, so that's part of our answer. Now we can find the sum of the series by using Sn equals n/2 times the first term plus the final term. Or not, yes, pi, sorry. So we had 17/2 times 3/4 plus 51/4. So this is 54/4. So we have 17/2 times 54/4. Okay, so we do have a fraction that we're going to deal with here. Okay, so let's get what we get here. 54 times 17 equals 918/6. There's our answer. Now, we can maybe, that's Sn. We can maybe simplify that because we can take 2 out of it at least to simplify it. In fact, it comes right down to 153. So don't be afraid of using fractions if you have to. Okay, so that takes us into about 29 minutes. So I don't want to go too much longer. I'll give you some practice work from section 1.1. 1.2, pardon me. So section 1.2, we're looking at arithmetic series. This is on page number 27. Okay, and you can work through, let's do 1 BCD, 2 BC, 3 ACE. We're just giving you some, and 4 BD, and 5 AB. Okay, so that'll give you some work there. Let me take a quick look here. Page 27, make sure. Okay, there's some word problem work there, which we'll probably look at the next day in that section. So that should be, I think, enough for today in that section. You can work on those, and if you have any questions, go ahead and ask them. Good luck.